Welcome back to Pratik Academy. In today's video, we will see Kelvin-Planck statement related to second law of thermodynamics. So, Kelvin-Planck statement. Kelvin-Planck's statement. Let's see its statement first. It states that it is impossible to construct a heat engine working in cycle whose sole purpose is to convert all the all the heat supplied to it into work. So this is Kelvin Planck's statement. It states that it is impossible to construct a heat engine working in a cycle whose sole purpose is to transfer all the heat supplied to it into work. If you carefully observe this statement, then here there is a word impossible. That means approach of this statement is negative. So this statement is having negative approach. First point, this statement is having negative approach. Again, it is related to heat engine. It is related to heat engine. So then what is heat engine? A heat engine is a device which takes input energy as a heat or thermal energy and gives you mechanical energy as output. That is, heat engine is a device which takes input energy as a heat. Okay, it takes input energy as a heat and convert it into work, or output from heat engine is work or mechanical work. Then again, it is impossible, it is related to heat engine. So that means Kelvin Planck's statement is related to one of the impossible heat engine. Then what it says or states, it states that heat engine working in cycle whose sole purpose is to convert all the heat into work. Okay, that means a heat engine which converting all the heat into work is not possible according to Kelvin Planck's statement. Then let's draw this, or for this statement we will draw one diagram. So this statement is related to heat engine. We will take two thermal reservoirs to place our heat engine. TH, high thermal reservoir, low temperature reservoir, and here let's place our heat engine E. So as this is the heat engine, it is taking input energy as a heat. So let's take QH is the heat from high temperature reservoir. Then what is impossible? It is impossible to convert this all heat into equivalent amount of work. So all the QH will not be, or all the QH is converting into work is not possible according to this statement, because this is a having negative approach here. Then what is possibility then? Then for possibility. Let's again draw heat engine between two thermal reservoirs TH, TL. Okay, let's take E is a heat engine which will take, or QH is the heat supplied to heat. Then this heat engine will reject or always reject some heat QL to low temperature reservoir, and remaining heat will convert into work. Remaining heat, that is QH minus QL, will be converted into work, and this engine is possible according to Kelvin-Planck's statement. Okay, now let's take how to check performance of this heat engine. So for checking performance, we have one parameter, that is efficiency. Again here, heat supplied is thermal, sorry, energy supplied is thermal, output is mechanical, so we will check thermal efficiency. Thermal efficiency, we have simply efficiency as output upon input. Okay, this is a simple one formula, we know that. Then here output is work W, and input is heat supplied QH. Then it will become W is again QH minus QL upon QH. If we adjust this, this will become 1 minus QL upon QH. So this is thermal efficiency formula to check performance of any heat engine. Okay. Again, as we know that QL here, if we take all QH is converted to work, and this is impossible. That means here in this case QL is 0. Okay, so QL is 0 is not possible. So QL is always greater than 0. That means this term here is always positive and having, or it is always positive. That means our thermal efficiency is always less than 100%. Okay, that means 1 minus anything will result in less than 100% thermal efficiency. So this is again one of the corollaries of second law of thermodynamics, which states that it is impossible to have a thermal engine or heat engine which will have 100% efficiency. So this is all about Kelvin-Planck's statement. So let's revise quickly. Statement is negative approach. It states that it is impossible to construct heat engine working in cycle whose sole purpose is to convert all the heat, remember word, all the heat supplied to it into work. So this is impossible. Then what is, so all QH is converting to work, this is impossible. Then what is possible? Possible thing is here, or possible diagram is here. It means QH, some heat is rejected, some non-zero heat is rejecting always to surrounding, and remaining is converted into work. Then how to check performance? For performance checking, we have thermal efficiency as output upon input, that is W upon heat supplied, and after adjusting term we get here thermal efficiency is equal to 1 minus QL upon QH, and as QL always greater than 0, that is always positive, therefore our thermal efficiency of any possible heat engine is always less than 100%. So this is all about second law of statement, second law of thermodynamics. It's Kelvin-Planck statement. In next video we will see Clausius statement of second law of thermodynamics. If you like this video, please subscribe our channel. Thank you for watching.